Today, I want to work out these problems, explaining how we get the answer. I do understand that some of these problems are a little more complicated and more in depth at the beginning of the semester. I'm using these as an example of ways of actually putting your work into the computer in Canvas. This is a good practice. So I'm going to go over it. So let's do number one. Number one says that we have 2 square root of 3 divided by square root of 5. And I want you to simplify this, and I want your answer to be in the simplest form, and it has to be radical. I don't want decimals, because if you use a calculator, that's what it's going to give you is decimal forms, unless you got a fancy calculator. So, but I'd rather you know how to do this and understand why it is before you start relying on technology to give you the answer. So, in a fraction, there's things that we cannot have in the denominator, and we have rules. And one of the rules is if the denominator equals 0, then we have an undefined answer, meaning that it's just undefined. So a rule is we can't have a root, negative number, imaginary number, 0 in the denominators. All of them but the 0 are easy to work with. We can use a rule to undo the radical, imaginary number, negatives, or whatever it may be other than 0 on the denominator. Where 0, if it's 0, that's all we have. So let's solve this one here. I'm going to use this ink here, and please bear with my writing. So I'm going to say this is equal to, and actually I don't want to say equal to. Let's start over. Let's say that we need to figure out what I need to multiply this fraction by in order to undo the denominator, because the denominator has a square root. Well, I know that if I multiply a square root times a square root, that becomes 1, and whatever's inside of it, which is my radicand, is what I'm going to be left with. So whatever I do to the bottom, let's do to the top. All right, so I'm going to rewrite this. I know that I have 2 times the square root of 5 times the square root of 3. So here's 2, and then over here in parentheses, I got the square root of 3 times the square root of 5. And I'm doing an extra step. Some of y'all are going to be like, I don't need this extra step. I'm just going to use it so that way you can understand when I combine these how it worked. And my writing's a little big. I hope you can bear with me. I'm a little. Okay, here we go. So now in my numerator, I noticed that my roots here, this root and this root are alike. As long as they're alike, I can put whatever's in the root together. So therefore, I got the square root of 3 times 5 because the roots are alike. If they were different, we couldn't do this. All over, and again, same here. These roots are the same, so we can put the radicand under the same root. Okay, so here we go. So some of you are already seeing the answer, which is cool. Let me scroll down just a little bit. So now what do I have? I have 2 times whatever's inside that root in my numerator. So when I look at what's inside that root, I got 3 times 5, which we know is 15. And the square root of 15 is just going to be square root of 15. You're not going to get a clean answer. If you get a clean answer, I want you to simplify it. But if you look at it, 3 and 5 multiplied is 15. If I look at what root this is actually the second root. We don't write a number here because the second root is the smallest root. If it was a third root or a fourth root and so on, we'd write the number here. But since it's a second root, that means whatever's inside here needs to be double in order for it to factor out. And I'm fixing to show you what I mean by that. Let's look at the denominator. The denominator is 5 times 5. Well, we know what that is. That's 25. But I was saying, since it's a square root, that means it's a 2, right? The root is a 2. Then that means I need 2 of the same, And just a little side note, let me get this red ink here and let's just say, we know that 5 times 5 is 5 squared. Well, then I have this root here, right? And the rule says if my root and my square are equal, so let's rewrite it based upon my power versus root. It's going to be power on top of my root. If these are equal, what am I left with? 1, right? 5 to the first power. We're left with 1 up here, which is just 5. So when I come over here, I know this is 25 because 5 times 5. I also know the square root of 25 is 5, and this is why this rule here applies. So let's go back and change this color, and let's finish this up. So the numerator is 2 square root of 15 divided by 5. And this is my final answer. And why is it my final answer? Because I cannot reduce. 2 does not reduce with 5. So whatever's on top does not reduce with the denominator, then I'm as far as I can go. Now, we have to leave the root alone. We can't just say 2 will go into it or 5 go into 15 because 5 is no longer in the root. So that is my final answer. On this next one, a lot of y'all said it was very, very simple and easy. And thank you for saying that. But to the ones that are struggling, please don't feel bad about it. What I did is I picked something that I was hoping would be very obvious for you to see as a practice run. But if you don't see it, I understand. That's okay. I know that 44 is a product of 4 times 11. I know that 55 is a product of 5 times 11. And whenever we're talking about roots, or excuse me, we're talking about fractions, we call them ratios. Whenever we're talking about that, we always look at a number on top and ask, does it reduce with a number on bottom? In this case here, my 11s reduce with each other, meaning that it goes into itself 1 time, right? If it goes into itself 1 time, then that means I got this 4/5 times 1, and my final answer is just 4/5. So this is my final answer. So let's move on to one that's just a little more complicated, guys. I asked you to simplify the following. Show all work possible, express answers using positive exponentials. Please read my directions, because if you notice on 2, I wanted it left. I just said simplify the following, but I really wanted it left in fraction form. There's going to be times I'm going to be real specific. So whenever we're talking about exponential rules, I do understand that this sometimes this can be more complicated, or you haven't learned these. So I'm going to be posting the rules on exponentials pretty soon. But whenever we do exponentials, we have a set of rules. We have the product rule, we have the quotient rule, the product of power of product, and negative powers. But anyways, we're going to learn all about that. But let's talk about it here. There's many different orders we can do first. Some wants to clean up the inside, then distribute the outside. Some wants to do the outside, then the inside. I'm going to do the outside first, only because this is my pattern. My outside is that I've noticed that this right here is a negative power. We cannot have a negative power as a final answer. So in order to make this positive, the negative rule says that we have to flip whatever has been raised to that power. Take the reciprocal. So since this is a negative power, I want to make it a positive. That means everything inside here needs to be flipped. That means whatever's on bottom is on top now, which is in my numerator. Whatever was in my denominator is now in my numerator. We don't change the powers inside the denominator and numerator. We're just flipping. Okay, we're just flipping. And once we flip the inside, what happens is it makes the outside become positive. So let's go ahead and let's do the next step. Now we can distribute this 2 to everything in here, or we can clean it up first. I prefer to clean it up before I start distributing. So that I noticed that I have 2/6. Some of y'all would have said I would have reduced that before I did anything else, but that's okay. I'm going to put the constants together. And then I noticed that I have what? A to the 7th all divided by a squared. And then, of course, we got to put the square back on here. And then I have b to the -6 divided by b to the -3. All right. So what I want to do, of course, we have many options here. I'm going to go ahead and reduce this. I know that 2 goes into itself once, right? So if I was to say 2 goes into itself once, 2 goes into 6 3 times. So now I'm left with I'm left with 1/3. Guys, I'm not skipping steps. Some of you may skip these steps, and that's okay. Okay, so now let's look at the next one. The next one, you can see, look, we have like bases, right? We have a raised to the power, a raised to the power. So these are called bases. If my bases are alike and I'm dividing, then I subtract my powers, and it's always top minus bottom power. So I'm going to rewrite this as a, because that's my base, guys. If you look, they're the same, right? That's my base. Where in the first parentheses, 2 and 6 was not the same, so we could not call them a like base. So here we go. A is like base, and when we divide, we always say top power minus bottom. So that means we got 7 minus 2. Let's go to the next one. And the next one, if you notice, we do have a like base again, right? We have b's here. And we're dividing, and whenever we divide, we always say top power minus the bottom. And if you notice that the top power is negative and the bottom power is negative, and we said minus here, it's very important, guys, that you make sure that you set this up correctly, because you will get the wrong answer if you don't. I'm going to go ahead and I want to distribute this 2 to everything inside my parentheses on this first one. So I know 1 squared is just 1. 3 squared, that's 3 times 3 is 9. So let's move on to the next parentheses. We need to clean it up. We got 7 minus 2. So we got a raised to 5. And it's all raised to the 2nd power. And then this next one here, what do I have? I have b. And I said I have -6 minus a -3. So I'm going to come over here just a little side note so I can show you. So if you have -6 minus -3, the rule says that this here, negative times negative becomes a positive. So now this turns into -6 plus 3. What is -6 plus 3? Well, that's -3, because that's like saying my bank account, I'm in the hole $6, but I deposit 3. How much am I in the hole now? I'm still in the hole, but not as much. I'm in the hole $3. So this stays as a negative power. All right, so moving on, we're getting closer, guys. This one's a little bit lengthy, and my writing's not perfect. I do apologize. I hope it's readable. Please let me know if you have any questions, okay? So my first one is 1/9. I'm going to go ahead and leave that alone just for now. And whenever we have a base raised to a power, and then we raise it to another power, we always multiply the powers. So 5 times 2 is 10. And over here, we got b raised to -3 raised to 2. Again, when we have it raised to a power, raised to another power, multiply. So -3 times +2, it's going to give me a -6. Okay, so to finish up, guys, we have to make sure that our powers are written in the positive form. So in my numerator, I got 1 to the first. It's positive. It's just 1. And then, and if you want to, we can just write an extra step here so that way you know what happened to the 1. And then I got a raised to 10. It's positive, so I'm not going to move it. I'm going to leave it on top. This b, though, is raised to a -6, and we can't have it as a negative power, so it's already on top. That means we need to put it on bottom. And what did I miss? I missed the 9. So let's look at the 9. The 9 is raised to a +1, so we're not going to move it. And I need one more step because we don't want to leave 1 times something. That's not simplest form. 1 times a, we all know it's just a. Whoops, let's rewrite that a little bit neater. So that's going to be a to the 10th divided by 9 times b to the 6th, and that is our final answer. Very good, guys. So we're moving on. Let's do the next one. Number 4 says, simplify the following. Shall all work possible? Express answer in simplest radical form. Guys, the reason why I'm doing all this work is because I want you to show as much work as possible in your work and your answers. And the reason being is mathematics can be done multiple different ways. I get that. There is one rule, but you can do them different ways. So here's the thing. If I see your math work and somewheres you went off a different direction and it yielded a wrong answer, you can get credit for what you did right. And I can also explain to you or show you where you went off. That way it will help you do better. If all I saw was an answer, then I really couldn't help you. It's either wrong or right? So we need to show our work, and we're all human. So earlier I was talking about the square root, and I said whatever's inside the root has to be in groups of whatever this power is. Or this index, excuse me. And this index in this case here is the 5th. So that means whatever I multiply to itself, it needs to be multiplied to itself 5 times to get what? Well, in this case, we're wanting 64, right? So here it is. We're going to say 64. Some of you may want to do a pyramid, a tree. You could do multiple different things in order to factor down what it is. People do ladders as different ways. What if we use 2? And I always try to stick all my prime numbers on the outside of my tree, my factor tree. 2 goes into 6, 3, and it goes into 4, 2. So 2 times 32 is 64. Well, let's try 2 again. 2 goes into 3 once, leaves me with 1, that's 12. So 2 goes into 12 6 times. So let's try 2 again. 2 goes into 16 8 times. So let's factor 8 down. Well, we know 2 goes into 8 4 times. We're almost done. 4 still likes one more step, right? 2 goes into 4 2 times. So over here, we're going to prime factor 64. And that's what I did. 2 times 2 times 2 times 2 times 2 times 2. And if you're unsure, multiply all these numbers together that are prime. Leave these outside ones alone. These outside ones here are not prime factors. So I'm going to look at it. I said I want groups of 5s in order to factor out because it's the 5th root, right? So I got 1, 2, 3, 4, 5. So what do I have? I have 2 to the 5th power times what? Oh, we got a 2 left. Sometimes, guys, you're still going to be left with something else. Not all the time, but sometimes. So we're left with 2 here. This means that I have 2 to the 5th power divided by the 5th index, 5th root, times 2 to the, this is a 1 here. We just don't usually write it because it's simplest form. 1st power divided by the 5th root or 5th index. So let's look at it. 5 divides 5 gives me what? Gives me 1. This gives me 1. So if that's equal to 1, then I'm left with 2. Correct? Well, this right here, it doesn't factor down. I'm still left with 1/5. So I'm going to put it back in that root because I couldn't factor it out. Therefore, this is my answer. And our last but not least, completely simplify the following. Show all work possible. So what I see here, oh, guys, I got a typo. It happens. There we go. We're all human, so it's always good to double check your work, okay? Just know that we're all human and we do make a little bitty typos. But anyways, whenever you're completely simplifying any equation that we got going on, equations, terms, whatever it may be, if you have a variable in there in adding or subtraction, so look, you notice these parentheses are separated by add or subtraction, then we have to follow a certain rule. If this here was multiplication, we could distribute, but this is not multiplication, guys. This is subtraction. Subtraction and addition has their own rule. This says here that we need to take this negative sign and distribute it to everything in the parentheses behind it. So if that's the case, then I'm going to leave the first parentheses alone. Because why am I leaving it alone? And I'm bringing it out of the parentheses is if you go look in front of the parentheses right here, go right here and look, there is it's only positive there because if it's negative, you'd see it. So there's nothing there to change it. So I'm going to pull it out of the parentheses. But here we go. Negative times positive gives me what? A negative. Negative times negative gives me a positive. Negative times positive gives me a negative. So here we go, guys. Now, we're almost done. We have to follow the rules. What does the rule say? Whenever you add or subtract anything, they have to be like terms. You can't take an apple and an orange and put them together and get grape juice. It just doesn't work. So adding subtraction says take all like terms. This and this is a like term. And if you notice that this is a positive 6x squared and this is a negative 6x squared. And if that's so, then that means they factor each other out. It's the same as saying I deposit $6 in the bank and then I spent $6. Therefore, I have a 0 there. So those go away. So we can mark them out. So now let's do the next one. The next one is a positive 3x plus a positive 3x. So this is the same as saying I deposit $3 in the bank, and I deposit another $3 in the bank. So I have a total of $6. So we'd write it this way. And then we got one more term left. This term here is a -10 and a -5. So this tells me that I am in the hole $10. I spent $5 more. So I am in the hole $15. Therefore, my final answer here, guys, is 6x minus 15. And that is solving our equation.